The Musical Instrument Digital Interface, better known as MIDI, is a communication protocol between electronic musical instruments. MIDI is both a programming language and a set of standards MIDI devices must adhere to. With the explosion of electronic musical instruments, like early synthesizers in the late 1970s, musicians began exploring the concept of creating sound using musically tuned voltage oscillators. Manufacturers, inventors, and musicians began creating a world of devices, all with their own operations and complex workings, capable of making sounds not currently possible with traditional instruments. MIDI was created in the early 1980s as a collaborative effort between some of the leading electronic music manufacturers to create a standard language of code for electronic instruments and devices to communicate with each other. MIDI devices come in a variety of functions and sizes, but they all communicate with this standard programming language. MIDI devices can be synthesizers that can create sounds, samplers that can record snippets of sounds and play them back as MIDI notes, drum machines which can play drum beats, and sequencers that can record and play back performances and songs. Let's dive in and understand more of this coding language. An introduction to the MIDI language. MIDI is a digital language that works off of a binary code, just like your computer uses ones and zeros to describe the information. The MIDI language describes all sort of information about a player's performance in order to describe the most detail about the sound as possible. MIDI also sends tempo and song position information from multiple devices to sync together and be in time. There are many different types of MIDI event data that make up the overall language that help the musician's performance get captured and played back. All these types of MIDI note messages aid in controlling the sound and the depth of the sound you can play and program. MIDI information consists of note data describing what note was played and how hard that note was pressed. Continuous controller data that describes any knobs or parameters being changed throughout a performance, like a synthesizer filter sweep. Bank and program change that allow on-the-fly changing of different instrument presets on a synthesizer. Aftertouch that describes how the keys are held after the initial note is hit for more advanced programming expression. System exclusive information, which is an early way for MIDI devices to save their settings to a sequencer. All these types of MIDI note messages aid in controlling the sound and the depth of the sound you can play and program. Traditional MIDI routing. Now that we understand some of the different bits of information that make up the MIDI language, let's talk about how we make all these different MIDI devices connect and talk to each other. MIDI devices are connected to each other through the use of a 5-pin serial interface connection. All MIDI devices have both in and out connections and sometimes through connectors for these standard cables. MIDI devices are traditionally daisy-chained from out to in of the next device. Since MIDI is daisy-chained from device to device, they all receive the same information to each other. So, how does each instrument know what to play? MIDI is comprised of 16 channels for note data, very similar to your cable television set. Devices or instruments are set to read each channel that pertains to them, even though they are all sent the same information. Now that we know how to connect devices, we need to get a better picture of what type of devices are out there. There are a variety of musical instruments that use the MIDI protocol, but traditional routing is controllers play the notes, sequencers record the notes, and sound modules make the sound. MIDI devices, called controllers, capture the performance and send a MIDI signal to sequencers, which record and let you edit the performance. And then they route the signal to the sound module, whether it be a synthesizer or a drum machine or a sampler. Pro Tools MIDI Studio setup. Pro Tools plays the role of a sequencer and allows you to record, edit, and play back MIDI information. Now, in order for the computer to connect to a MIDI device, it must connect via USB to a MIDI interface. A MIDI interface allows the computer to communicate MIDI information via its USB port. Our MIDI interface in the Melrose Audio Studio allows the same functionality. In Pro Tools, you can set up and name devices hooked up via MIDI in the MIDI Studio setup. This allows Pro Tools to show a device, names, and gives the program a better understanding of the MIDI device connected. In the MIDI Studio setup, the devices are named and working channels are labeled. There is also a very extensive list of popular devices from a variety of manufacturers. On a side note, in the Melrose Audio Studio, we communicate with the Avid preamps and control them as MIDI devices. This does not transmit audio, but only preamp control information. We hope you have a further understanding of MIDI and the role it plays in modern music production. There is a wide world of electronic instruments and MIDI devices to help you explore your creativity.